This is Maya's lesson on prime factorization. First, let's do a quick review on factors. When we multiply two numbers, such as A and B, together, we get what is called the product of A and B. We call A and B the factors. Many numbers have more than two factors. For example, 6 times 2 equals 12, and 3 times 4 equals 12. So for these, 6 and 2 are factors of 12, and 3 and 4 are factors of 12. So 6, 2, 3, and 4 are all factors of 12. And if you notice, they come in pairs. So factors come in pairs. Let's review prime and composite numbers. A prime number is divisible by only the number 1 and itself. For example, the number 13 is only divisible by 1 and 13. Those are the only two numbers, which makes 13 a prime number. Numbers that are divisible by more than two numbers are called composite numbers. For example, the number 45 is divisible by 1 and 45, 3 and 15, 5 and 9. So all of these numbers are factors of 45. The numbers 1 and 0 are neither prime nor composite. In the previous section, we saw how to write composite numbers by the products of their factors. For example, 12 may be represented in several different ways. 6 times 2 equals 12, and so does 3 times 4. But we could also break it down even more and write it as 3 times 2 times 2, because 3 times 2 equals 6, and 6 times 2 equals 12. 3 times 2 times 2 is the prime factorization of 12, since all the factors are prime. The prime factorization of a number is the number written as the product of its prime factors. So you may ask yourself, how do we find the prime factorization of a number? Well, let me show you. It's going to be very similar to finding the factors of a number. To find the prime factorization of a number, we make a factor tree. Let's try our first factor tree for 180. So the first thing you need to know is when you use a prime number, we're going to circle it, and then we stop using that branch of the tree. So let me give you an example. Here's our first branch for 180. I know 180 is an even number, which means that it's divisible by 2. Now I just have to figure out what 180 divided by 2 is. 180 divided by 2 is 90. Now let's take a look at those two numbers, the two factors of 180. 2 is a prime number, which means we can circle it and stop with that branch. 90 is an even number, which means it's not a prime number because it's divisible by 2. So we can start 2 more branches off of 90. So we know 90 is an even number, which means it's divisible by 2 again. 90 divided by 2 is 45. So just like last time, we have to look at those two factors, 2 and 45. Are either of those numbers prime? Yes, 2 is another prime number, which means we can stop with that branch. Now we have to look at 45 again. So 45 is going to have 2 branches of its own. I know that 45 is divisible by 3 because 4 plus 5 is 9, and 9 is divisible by 3. Now, 45 divided by 3 equals 15. Now we have to look at these two numbers. Are either of these two numbers prime numbers? Yes, 3 is a prime number, so we're going to circle that one and we can stop with that branch. But now 15 is going to have 2 branches of its own again, because we know that 15 is divisible by 3 again, because 1 plus 5 equals 6, and 6 is divisible by 3. 15 divided by 3 is 5. Now we have to look at both of these numbers, 3 and 5. Are either of these prime numbers? Yes, 3 and 5 are prime numbers. So the prime factorization of 180 is 180 equals 2 times 2 times 3 times 3 times 5. We can actually also write it as 2 squared and 3 squared because there's 2 of both of those. So 2 squared times 3 squared times 5 would be our prime factorization of 180. Let's do another example. If we have the number 16, what are the prime factorization for 16? We're going to start with the 2 branches. Now, I know that 16 is divisible by 2 because 6 is an even number. 16 divided by 2 is 8. Now, I have to look at these two numbers. Are either of these numbers prime numbers? Yes, 2 is a prime number, so I circle 2, and that branch can be left alone now. So now all I have to worry about is 8. So I'm going to put 2 branches now on 8. Well, 8's also an even number, so it's divisible by 2 again. 8 divided by 2 is 4. Now we look at these two numbers, 2 and 4. Are either of these numbers prime? Yes, 2 is a prime number, so we circle that number and that branch is done. But 4 is an even number, so I know it's also divisible by 2. What's 4 divided by 2? 2. Are either of these numbers prime numbers? Yes, 2 and 2. So the prime factorization for 16 is 2 times 2 times 2 times 2, or 2 to the 4th, because we have 1, 2, 3, 4 2's. Now what have you thought of a different way to do 16? I'm going to show you another way that you could have factored 16 with a factor tree. So what if I think, well, yeah, 16, I know 4 times 4 is 16. Are either of these numbers prime? No, they are not, which means that I actually have to keep going on both branches. So I'm going to add 2 more branches to each number. So if a number is not prime, you're going to add branches because you have to continue to break it down. So what can we divide by 4? Well, we know that 4 is an even number, so you can divide it by 2. 4 divided by 2 is 2. And hey, look, we have the same exact number, so 4 divided by 2 is 2. Now, do we have to continue our factor tree? No, because 2, 2, 2, and 2 are all prime numbers. So our answer for 16 is still 2 times 2 times 2 times 2, or 2 to the 4th power, because it's 2, 2, 2, 2, 4 times. Let's do another example. We have 45. So we're going to put 2 branches on 45 because we know that it's not a prime number, so we can divide it. So 45 I know is divisible by 5 because the last digit is 5. And 45 divided by 5 is 9. Now I have to look at these two numbers. Are 5 or 9 prime numbers? 5 is, so I'm going to circle 5 and I can stop with that branch. But 9 is not, because 9 is divisible by 3. And 9 divided by 3 is 3. Is 3 or 3 a prime number? Actually, they both are. So you're going to circle both of them, and that means that you're done because you don't have to add branches to prime numbers. So if we look at this, our answer would be 5 times 3 times 3, or 5 times 3 squared, because we have 2 3's. Let's do our next example, 72. So first we have to make sure that 72 is not a prime number. Well, 2 is an even number, so we know that it's divisible by 2. So we're going to make our 2 branches. We're going to start by doing 2. So 72 divided by 2 is 36. Now we have to decide, is 2 or 36 a prime number? Yes, 2 is a prime number, so we can circle it and stop using that branch. But 36 is not a prime number, so we have to make 2 more branches off of 36. So 36, let's see. I know that 36 is divisible by 2 once again because 6 is an even number. So 36 divided by 2 is 18. So 2 and 18, are either of those a prime number? Yes, 2 is a prime number again, so we have to circle it and stop with that branch. But 18 is not, so we need to make 2 more branches off of 18. Now 18 is also an even number, so it's also divisible by 2. 18 divided by 2 is 9. Is 2 or 9 a prime number? 2 is, but 9 is not, because I know that 9 is divisible by 3. 9 divided by 3 is 3. 3 is prime number. So now we stop because the last 2 that we just had are prime numbers. So the prime factorization for 72 is 2 times 2 times 2 times 3 times 3, because I'm using all of these numbers that we circled. And that's also equal to 1, 2, 3, 2 to the 3rd times 3 squared. So it's either 2 times 2 times 2 times 3 times 3, or 2 cubed and 3 squared. Now remember, there's more than one way to do a factor tree. So if you were thinking of 72 as and doing something else with the factor tree, like maybe 8 times 9 equals 72, that would work out too. Let's figure that out. So 8 is not a prime number, and neither is 9. So that means we have to put branches for both of them. So 8 is an even number, so we know it's divisible by 2. And 8 divided by 2 is 4. And let's look at 9. 3 and 3. Now, we can stop with that branch, and that branch, because 2, 3, and 3 are all prime numbers. But 4 is not a prime number, so we need to put another branch on to 4. 4 is divisible by 2, so 4 divided by 2 is 2. Now we can stop because 2 and 2 are prime numbers. So our prime factorization for 72 ends up equaling the same thing. 2 times 2 times 2 times 3 times 3, or 2 cubed, because there's 1, 2, 3 2's, times 3 squared, because there's 2 3's. Our next example is the number 70. So, like I've been saying, you can do these in different ways, but let's start by doing 70 this way. So I know that 70 is divisible by 10 because it ends in a 0. So I'm going to have 10, and 70 divided by 10 is 7. So is 10 a prime number? Nope. So we're going to have 2 branches there. And is 7 a prime number? 7 divided by 2, nope. 7 divided by 3, nope. 7 divided by 4, nope. 7 divided by 5, no. 7 divided by 6, no. Oh, I guess it is. It's a prime number, so I can circle it. So I'm done with that branch. We don't have to keep going. Now, 10. I know 10 is divisible by 2 because 0 is an even number. 10 divided by 2 is 5. And I know from before, because we've been working with this now for a little bit, 2 and 5 are also prime numbers. So I'm done. So my answer is 2 times 5 times 7. Our next example is going to be the number 23. So first we have to decide, is 23 a prime number? 23 divided by 2, no. 23 divided by 3, no. 23 divided by 4, no. 23 divided by 5, no. 6, no. 7, no. 8, no. 9, no. 10, no. If I keep looking through this, it doesn't seem like 23 is divided by anything except for 1 in itself, which means it's a prime number. So when you have a prime number, its prime factorization is itself. So the prime factorization for 23 is 23. Don't have to do anything else with that one. All right, let's do one last example. 9. So we're going to start by making sure that 9 is not a prime number. Is 9 a prime number? No, I know that 9 is divisible by 3. So 3. 9 divided by 3 is 3. Wait a minute, 3 and 3, they're both prime numbers, so I can just circle them both. Wow, that one was easy. 3 times 3, or 3 squared.